So thank you.
Can everybody hear me okay? Yep. Thank you, Garth, for that introduction and saying some things that I'm not allowed to say. And when I first, I go around and talk about Hubble, Webb, and Roman quite a lot. I've included Chandra. Thank you, Lisa, for a few slides on Chandra. This talk, I also want to say thank you to the organizers for letting me give a non-science talk. This is an update talk. But I think this is an important talk, particularly for the early career scientists, to kind of understand how did we get this amazing machine Webb? What is the role of NASA Astrophysics Flagship missions in astronomy writ large? And what does the future look like? Because really the science is great, the missions are great. This is an incredibly exciting time to be doing science. And there are a lot of folks like Garth and Lisa and I who are trying to make sure that we keep that going. So just know there are a lot of people working very hard to keep things going. Okay, so how did we get here? So in the U.S., we're incredibly lucky to have a history of the community getting together every 10 years, writing a decadal report, and making recommendations both to NSF and NASA on what they should be doing. And so NASA Astrophysics Flagship missions have arisen out of this process, starting with Hubble in the 70s, all the way through Chandra, Spitzer, Webb. Garth talked about Webb as being something people worked on in the 90s. I remember that time. Roman is just around the corner, and the most recent decadal survey recommended World's Observatory, which is not just for exoplanets, and if I get time, I'll say a little bit more about that. Space Telescope has been fortunate to be part of this process from the beginning. We act as a bridge between NASA's astrophysics flagship missions, particularly the UV optical infrared ones, and the rest of the scientific community. When they were looking for a place for Hubble back in the 70s, this came from the National Research Council. Sorry, my things are being a little slow. I've got it running off of my phone because the internet was a little weird. Space Telescope Science Institute is needed to provide the long-term guidance and support for the scientific effort, to provide a mechanism for engaging the participation of astronomers throughout the world, and to provide a means of disseminating utilization of data derived from the Space Telescope. Why do we need such an institute when NASA exists? Well, it's really in our name, science. So Space Telescope Science Institute always puts science first, even in times when science is not the top priority at NASA. So we continue to advocate for science through thick and thin and support the scientific endeavor. What does that mean? Hopefully everybody knows this, but in case you're wondering, what do we do over at the Institute? I personally did not fully appreciate the full scope of this until I became a staff member. There are a lot of people working behind the scenes to make sure that you can do all that great work that you're doing with Webb, with Hubble, with future Roman, and I'm sure this looks very similar for Chandra, reviewing the proposals, helping people plan and command the telescope. For JWST, we have the Mission Operations Center at Space Telescope, so we actually talk to the telescope. We take that data, we calibrate it, we make sure it's processed properly. We put it into the archive, grants to the community through NASA's funding, and as well as support the community in telling their stories to the public. One of the major things that flagships do is provide support for astronomy across the entire United States. So this is a map of where Hubble and Webb proposals were in the last cycle, 44 states from Hubble, 47 states for Webb. This is a map of where the grants go. You can see, of course, California, Maryland, Texas, and Massachusetts have a lot of success, but it's really important to remember that the U.S. taxpayers are paying for this, and the people that make the decisions about NASA funding don't just come from California and Maryland. They come from these other states. And so this is one of the things that NASA flagships can do, is have this broad impact across the United States in astronomy and STEM. Of course, ESA makes up about 30% of our programs. We're a partnership with ESA on Hubble and Webb. And people from around the world publish papers with this data because we make it accessible to all. Another thing that having a flagship makes possible is to have these well-calibrated public archives that has dramatically increased the scientific return of these programs, and it also helps support the infrastructure for science. So AstroPi was supported by Space Telescope discretionary funding over 10 years ago, among other groups, and now is an incredibly important part of the scientific endeavor, and is integral in what we do for the data reduction pipelines, for Webb and Roman, et cetera. Garth mentioned this, but another important thing is outreach. And so, if you're thinking, how do I tell the story of how important this is, telling your story, why is your science important, to the public is incredibly important. And it really does translate into funding for science. So 25% of Americans have seen an image taken from space, like the images from Hubble and Webb. The people that see those images are much more likely to support NASA and think that the US should lead in space exploration. Some people think 25% is not a high number. I actually thought that was pretty good. But it's really important that we not forget the role that outreach has. All right, these are the detailed, scary numbers. So Garth pointed out that NASA science was cut in half. NASA astrophysics was actually cut by 2/3. And while I feel very fortunate that at least there was funding in there for Hubble, Webb, and Roman, the Webb number was really scary. A $47 million cut to Webb funding was proposed by the president, and specifically calling out cuts to grants. So I'm very glad. I think the House and the Senate numbers are much better. We hope that those come through. But if the president's budget comes to pass, there's going to be really difficult times across the board. And I know that other institutions have much more significant cuts, with many NASA missions being full out canceled. All right, so I'm going to talk about these missions. So I got this great slide from Lisa. Chandra's celebrated 25th anniversary. It remains the most powerful X-ray mission in the world, and it's going to continue to be that for the foreseeable future. And it's doing amazing science. The Senior Review commended Chandra, commended Hubble, and it's doing really interesting synergistic science. This science results looking at a redshift 10 X-ray AGN was really spectacular, and I think folks talked about that earlier in the week. Hubble has just celebrated its 35th anniversary. Last year was also its most productive year ever. It published more papers in 2024 than any previous year. It is expected to live till the mid-2030s. That depends on the solar cycle and the orbital decay. And its capabilities also will not be replaced anytime soon. The next successor to Hubble would be, or something that would supersede Hubble in the UV, would be the Habitable Worlds Observatory. One of the reasons why it keeps publishing papers is that the fact that it now has decades of incredibly well-calibrated data, which is opening up new kinds of science. So this was one of my favorite results from last year. So this is a picture of Omega Cen, a well-known globular cluster. It is actually a calibration field for Hubble. So Hubble goes back again and again and again. All of that data is publicly available in the archive. And what this group did was notice that when you look at that data, because it's so well calibrated and the astrometry is so good, they could see the motions of 7 stars and constrain the fact that there was an intermediate mass black hole sitting in the middle of this globular cluster. That's amazing. And so we're seeing that kind of science happening more and more, using that decade's worth of Hubble data to do things that you couldn't do in the first 5 or 10 years. Another unique capability of Hubble is its ultraviolet spectroscopy. So last year, a previous director's discretionary program known as Ulysses, which got UV spectra of hundreds of stars, did this study where they looked at 110 sight lines through the Large Magellanic Clouds, and were able to detect the signatures of outflowing gas along those sight lines. And that outflow velocity is in the Large Magellanic Cloud is proportional to what we see in other galaxies, proportional to the star formation rate per unit area. And this is the kind of science that we might expect with the future capabilities of habitable worlds on a much bigger scale. So I just have a few slides about JWST. It's performing better than expected. You know, it's a transformational for the field. It's ultra stable. We thought we'd have to focus JWST every 6 weeks. We're doing it every 6 months. Thanks to the amazing launch with the Ariane 5 rocket, we have over 20 years of propellant. We really think we could operate JWST for 20 or 30 years. And it's my job to make sure that we keep doing that. And in the last couple of years, there's been significant improvements to the calibration pipeline's GuideStar catalogs. If you have complaints, please come see me. We've been working on that. Casey is also on the JSTEC. But I think there's been a lot of progress. And, you know, this last few days have been fantastic. It's been transformational for early universe studies. And I just have to say, it's because of spectra, right? Really, being able to get spectra of galaxies above redshift 10 has been amazing. All of this to say is that JWST is not even close to hitting its peak of science or demands. We had 2,400 proposals in cycle 4. We might hit 3,000 in cycle 5, where the call just went out. There's been, you know, dramatic increase in the number of papers JWST has published. I think 25 will be the year that it breaks the Hubble record. We just have to keep going. JWST now has a place in the worldwide imagination, but there's real risk to being able to continue at this level given what's in the President's budget request. And even with a flat number, we are facing some pretty significant challenges with inflation. So I was happy to see a higher number in the Senate language. All right, Roman. Garth showed a few slides on this, but Roman is ready to go. It is 94% complete, and it also changed in the paradigm for NASA flagship missions in that it is on time and on budget. So they have figured out project management now for flagship missions. Here's some pictures. And this last one on the right is SCIPA, which is the combination of the telescope and the instruments being lowered into thermal vac. That was last week. It's just got a few more months of testing. We got to make that with the outer barrel assembly, and then it's going to be ready to head to the launch site. This group should be thinking about what they should be doing with Roman, right? So Roman is going to be synergistic with Hubble and Webb. What you would do with 1,000 years of Hubble, you could do in 10 months with Roman. The other important thing to know is because of the requirements needed to do the cosmology, its calibrations need to be an order of magnitude more stringent than what we have for Hubble or Webb. One of the driving science cases, of course, is to map out the universe at earlier ages. We heard a great presentation on Rubin. We heard a great presentation on Euclid. Those are going to be complementary to what Roman's doing. So Roman is deeper, not as wide of area. It's going to have optical and infrared imaging as well as GRISM spectroscopy. And so it's going to be able to push out questions about dark energy and the cosmology to earlier times than those other two surveys. All of the surveys have now been defined. You can go look at them. One of them might look familiar to the Candles team, in which they have adopted for the high latitude wide area survey a wide, medium, deep, and ultra deep approach, but with a lot more data. So there's a little zoom in there of where the deep field is for this survey. It's 2,000 times the area of the Hubble ultra deep field, 600 million galaxies with shape measurements. And for those of you who are used to looking at Hubble surveys, this is Cosmos, right? This little white plot. And that is the Roman high latitude wide area survey. So it's just going to be overwhelming. So the Cycle 1 call for proposals is coming up this fall. That will be for funding, mostly, to use the existing surveys, but there will be an opportunity to propose your own observations through general astrophysics. And that's expected to be due in March. All right, if I have a few minutes, I will talk about what's coming next. So what is Habitable Worlds Observatory? It's the next concept for NASA's flagship mission. It's really designed to look for signs of life on planets outside our solar system. We want to see if we can figure out if there's life on an Earth-like planet around a sun-like star. To do that, though, you need to build an incredible machine, a large aperture UV optical infrared telescope that could do a whole bunch of other things. It's not just for exoplanets. So this is the suite of proposed first-generation instruments. You've got the telescope. We're talking about 6 to 8 meters. Some of us would like that to be 10 meters, so that's not been fully defined yet. The coronagraph is what you need to directly image those Earth-like planets. It's incredibly difficult. You need a contrast ratio of 10 to the minus 10, as well as a very stable, ultra-stable telescope. That's pushing the technology development. There'll be a high-resolution imager with UV, visible, and near-infrared, a little bit like the WIF-C3 camera. And something that's interesting is a UV multi-object spectrograph. So UV and visible. We've seen how transformative spectroscopy has been for James Webb. This will be incredible as well. So, you know, there's a lot of discussion, momentum around that. So I would like this group to start thinking about what they might do with that telescope. There's a lot of science cases out there. One area I think it will be transformative in is understanding the baryonic cycle, the flow of gas in and out of galaxies. With that UV multi-object spectrograph, you could map out the Andromeda galaxy 250 times faster than Hubble to detect outflows. You could also probe a lot more lines of sight to distant quasars or potentially even galaxies to understand the CGM. So this is my next to last slide. Last week, we had a big meeting in Washington, D.C. on the Habitable Worlds Observatory. Those presentations are recorded and online. We had over 400 people there, and people really, you know, one of the goals of that conference was to take the science cases that had been developed over the past year by the START and put them forward. So really polished, beautiful talks. If you go to this website, you can see each of those science cases. You can read them. If you like them, you can endorse them. This is a perfect time for the community to start getting excited about this. All right, so I'm going to wrap up. We really are entering a new and exciting era of discovery for cosmology, exoplanets, and galaxy evolution too, particularly with simultaneous operations of Hubble, Webb, and Roman. Space Telescope is the bridge. NASA Astrophysics Flagship missions really have a broad impact beyond just the science that we've talked about in the last few days. They change the way that we do science, and they provide a mechanism for telling the world and the U.S. about what we do and why it's important. And the future is uncertain, but we'll, you know, I'm happy to answer questions about that. Thanks.
Questions?
That was a beautiful talk. I'm wondering, so when Roman goes up, there'll be HST, James Webb, and Roman. Are you concerned that oversubscription rates on each of those will, well, on Webb in particular, will go down as people move to Roman, and that might look like, you know, to people outside the community here who know what's going on, lower interest in Webb, and the same might happen to Hubble? And how would you be communicating that, you know, because we can't take on, as a community, yeah. I think we're all overcommitted, so I don't think, you know, we can take on additional work. People are going to move from telescope to telescope in what they do.
I think that's a possibility, but honestly, I'm not worried about that at all for Webb, actually. We did see a bit of a drop in Hubble oversubscription, but not dramatically. I mean, we still got 800 proposals last cycle, which is really high. And I actually think they're serving pretty different communities. So you've got the history of Sloan, you've got the people who've been working on Rubin. You know, they will also, and the Euclid teams, they will be utilizing these survey data. The point and shoot community focusing on slightly different things, there's different focuses there. Now, there's going to be a lot of overlap, and I'm hoping that people will find amazing things in the Roman big data sets that they'll want to follow up with Hubble Webb. But in the short term, I'm not real worried about it.
Thank you. Yeah, Jen, that was a great talk. Very positive. Nice to follow up my talk with a much more positive one. Thank you. So you reminded me about habitable worlds in a couple of different ways. And one is the importance of a new flagship as a way of continuing and building interest in Congress and across, again, the public, the outreach aspect. So HWO is particularly important. And I didn't visit, I wasn't there at the meeting in Washington, but I was online for a lot of it, and I was incredibly impressed with the interest, but also with the level of the technical developments that had happened. The current concept development is remarkably good for that mission and incredibly exciting, as you sort of mentioned, as folks at the conference, I think, displayed in their interest. So I think we're on a path there, because you noted that the Senate budget, and I'd forgotten to mention this, put in $150 million for development activities on HWO. Now, OMB wants to cut that to $3 million, which is nothing. So I hope the battle is won on that and some money is available to continue it, because that's crucially important for us, I think, because a flagship like that literally acts as a way to build up the whole program with the interest that it develops.
Yeah. Thanks, Garth.
So Rachel has a question there.
Thanks, Jen. Really nice. I just wondered if you wanted to mention what's happening with the PROBE program, because people may be less familiar with that.
I think the PROBE program is certainly at risk, and that's a real challenge. And I'm all yay flagships, but NASA needs that diversity of size of programs, right? You don't want to start with a flagship, right? You want to be able to train people and do more experimental things with smaller missions, more focused missions. And so, I know that if they're given the funding, NASA Astrophysics really wants to make the probes happen.
Yeah, I meant even maybe more specifically to let people know that there are two probe concepts that are currently in phase A. One is a far infrared concept called PRIMA. One is an X-ray concept called AXIS. I think they're both incredibly exciting. I happen to be on the PRIMA science team, but literally either one of them would be amazing, and it would happen much sooner than habitable worlds, which of course is also super exciting. But I think as we advocate, we should remember, exactly as Jen just said, to advocate for this whole portfolio of missions of different sizes and different timescales.
Yeah, that's a great point, Rachel.
Thank you. An applause for Jennifer again.